Welcome back. In this video, I will introduce the management and orchestration in mobile edge cloud. For the introduction, we know that MEC is distributed over the network, and in order to provide the low latency for the applications, we might need to deploy the thousands of MEC nodes, as you can see in this figure. And now, let's assume that you want to deploy an applications. So the question is where we can deploy and how to maintain the applications. This is very challenging. So in order to do that, we need to have a global manner that can provide the overview of the MEC nodes, an overview of the resources. That is why Management and Orchestration Framework stands for. In MEC, the Management and Orchestration Framework can provide an overview of the resources so that it can allow for the resource utilization. This is very important because normally in MEC, the resources are very limited. The Management and Orchestration Framework can also provide the automation of the lifecycle management. For example, using the Management and Orchestration Framework, we can create, update, and delete the applications. This is the advantages of management and orchestration in MEC. Because of the potential advantages of management and orchestration, so SE also provide a reference framework, as you can see in the figure. So SC MEC reference framework includes two layers or two levels. The first level is about the mobile edge system. So it's mainly responsible for receiving and handling the requests from users. And it can provide a global view of entire system, entire hardware resources. The second level is mobile edge host. So it accounts for the lifecycle management of the application on a specific server. So this is the two levels of reference framework. So SC framework can also interact with the 3GPP, local network, or even external network. Let's have a closer look into the reference framework. So let's assume we have a mobile device here, and in order to send the request to the framework, it can use a customer facing system or user app here. The request then go to the operating support system or either go to the lifecycle management proxy. Then the operating support system can provide the policies. For example, it can decide how much hardware resources needed to handle the request. Then the request is down to the mobile edge Orchestrator. Mobile Edge Orchestrator has a global view of resources. By interacting with the infrastructure manager in the lower layer, as you can see the interface here, after verifying the resources, the request is then sent to the Mobile Edge Manager. So Mobile Edge Manager will perform the lifecycle management of the applications. Specifically, it will interact with the infrastructure manager to deploy the application, or it can also directly interact with the mobile edge host. Now go back to the communication between the mobile edge manager and infrastructure manager. The request is then sent to mobile edge host. So in mobile edge host, we have virtualized infrastructure, so we can deploy our applications on top. And in mobile edge host, it can also provide other services for the applications, such as traffic rules control or DNS handling. This is the basic procedure of MEC framework. Now, I will talk about the real-world implementation of the MEC frameworks. As you can see here, the MEC framework will include different use cases. For example, we have a smart city, the autonomous driving, the e-health, video caching, or smart grid. And in order to support these use cases, there's a mapping between the features and the specific implementation. For example, in order to provide the bandwidth, we need to consider whether the MEC server have enough computation resources. And for the latencies, the MEC need to determine whether it has ability for the real-time interaction. So it depends on the distance between the MEC and the mobile devices. So there's also the mapping for other features, as you can see here. Now look at the right hand side. You can see the Edge implementation, the MEC implementation. Here I just mentioned few the MEC framework, but actually there are a lot of real-world frameworks. So as I mentioned here, we can have Archiro framework. We have a Edge Factory. We have an Airship. We have an ONAP. So now I will talk more detail about the MEC implementations. Before deep dive into each real-world framework, I will show the key software tools that is used for the management and orchestration in MEC. Normally, the real-world frameworks rely on two software tools. The first one is Cloud Platform. This is about the OpenStack or Kubernetes. And in order to provide the flexibility of the network, some frameworks consider the SDN platform, such as ONOS, and Calico. Now, let's talk about the cloud platform and SDN platform. So, in order to build the cloud platform, we need to consider the virtualization technologies, because the application will be built inside the virtual machine or is built inside the container. So what is about the virtual machine? Virtual machine is an emulation of the computer, so it can have its own operating system, as you can see here. So we have a physical server, and virtual machine is managed by a hypervisor. And inside virtual machine, we can see it has all operating system. Different from virtual machine, container is a standard unit of software that can package up the code and the dependencies for specific applications. So this is the architecture of the container. So you can see here the containers share the operating system of the host, and container is managed by Docker engine. There are also other container manager, such as Linux container. So you can see there's a major difference between virtual machine and the container. And the cloud platform, it is either built for the virtual machine or for the container. This is an example. So OpenStack is built for the management of the virtual machines. Let's first look at the definition of OpenStack. So OpenStack is a cloud operating system that can control the pools of compute, network, and storage resources inside a data center. So we can use the programmable interfaces to manage and to provision the resources. So you can see in this figure, these are applications you want to deploy, and you can use the API of OpenStack for the compute, networking, and storage resources. OpenStack can also provide the OpenStack dashboard. This is a friendly graphical interface for the users. And in the lower layer, you can see the standard hardware. Unlike OpenStack, Kubernetes is a cloud operating system that can manage the containerized workload and services. You can see in this figure. This figure shows the Kubernetes architectures. So Kubernetes includes two layers. The first layer is the master layer, and the second layer is worker layer. And the master layer can interact with the worker layer through the API. So the container will be deployed in the worker layer. This is the basic architecture of Kubernetes. Because of the simple design, so nowadays Kubernetes is very popular and is uh, adopted by many industries. And Kubernetes is lightweight compared to OpenStack because Kubernetes is targeted for the container. This is about the two cloud platforms. Now, let's talk about SDN controller platform. The first one is Open Network Operating System, or ONOS. ONOS is an open source SDN controller. It's used for the communication service provider and is designed for the scalability, the high performance, and high availability. This figure shows the architecture of ONOS. As I mentioned earlier in this lecture, so ONOS rely on the reference architecture of SDN. On top, this is an application layer. And we can see this control layer. And at the bottom, we can see the network devices such as routers and switches. So control layer interact with the network device through the OpenFlow or other APIs. Using ONOS, it can provide many applications such as host mobility, intent-based layer 2 forwarding, SDN IP peering, there's also another SDN controller platform. This is about the Calico. So Calico is an open source project that provides a simplified network model for containerized applications. So Calico is mainly proposed for the Kubernetes and is tightly integrated into the Kubernetes. So Calico controller will be deployed in the master nodes that you can see here. And in the worker nodes, Calico have an agent inside the worker node. So I already mentioned the key software tools that is used for the mobile edge cloud. And actually, there are a lot of the cloud platforms, also the SDN controller platform, but they are not currently using for mobile edge cloud. The first framework I want to mention is Akraino. So Akraino is the real-world MEC framework, and it is supported by the AT&T company. This is a telco company. And when you look at the architecture of Akraino, you can see every layer that can help you to deploy the applications. First, so the mobile devices or the user can interact with the framework through the graphical interface. So Akraino provides the dashboard for this. And for the inner request processing, we can see Arduino include the workflow, the APIs, and the orchestration and NFV orchestrations. And the lower layer, we can see the network edge and the customer edge. So Arduino includes several OpenStack framework you can see here. But in this figure, I want to highlight that the Arduino is also adapted from the SC MEC MEC. For example, Arduino use the reference of the management and orchestration. And as I mentioned before, for the MEC platform, Arduino use OpenStack and Kubernetes, and for storage, is used CEPH. And for the SDN container, it's either use the simple SDN or use Calico. In order to speed up the processing, Arduino use the OVS DBK and the container interfaces. So that is the basic architecture of Arduino. The next framework I want to mention is the Airship. So Airship is also a product of AT&T company. In Airship, I also want to emphasize that the orchestration and management is also adapted from SC MEC framework, as you can see here. And in the lower layer, we can see that OpenStack is also used in the Airship framework. There are several services in OpenStack can be used in Airship, for example, like Keystone for the security service, and Nova for the compute service, Neutron for the networking service, and HIT for the orchestration services. So you can see that OpenStack is widely used for the MEC framework. And for the networking, Airship used the Calico for the SDN networking solution, and CPS for the storage. And you can see that Airship also include other cloud platforms such as Kubernetes. This is a container platform. In the lower layer, we can see, of course, we have the host operating system and the bare metal device. So Airship, you can see here that is include the cloud platform and the under cloud platform. The next one is Starling X. So the Starling X now is very active project. So you can see the architecture of Starling X. Currently, Starling X is Starling X is organized by the WinDriver and the Intel company. So currently they are contributing to Starling X. And for the framework, Starling X include container nodes and worker node. So it also can support the virtual machine or and container. And you also can see that in Starling X, so OpenStack is also used. They use compute service and the networking service in OpenStack. And in the lower layer, we can see that CPH, the storage service, and Keystone security service are used in the Starling X. For the container platform, we can see the Kubernetes, Docker, and Calico here. And in order to speed up the processing, OpenVSys DBDK and SRIOV are also used here. So another MEC framework is CORD. So CORD is built on top of the ONOS. This is an SDN controller. And you can also see that for the cloud platform, CORD use OpenStack and Docker. OpenStack can provide the virtual machine management, and Docker can manage the containers. So they use together with the ONOS. And on top, we can see that the core framework can provide the applications such as subscriber as a service, internet as a service, and monitoring as a service. So to deploy the applications, first the core will talk to the OpenStack or Docker, and for the network, it will talk to the Osnode controller. This is about the core architectures. Another framework is Virtual Central Office. Virtual Central Office was proposed by Red Hat company. And now we can see that Virtual Central Office is also based on the SC MEC framework, the reference framework. What we can see is, so this for the management and orchestrations. And in the lower layer, we can see the management. In Virtual Central Office, we can see the OpenStack, the cloud platform here. And for the networking, is used SDN controller, which is OpenDaylight. This slide shows the architecture of SX Factory. So SX Factory is organized by many companies such as Intel, HP, and Dell. So in SX framework, you can see that it can provide the not-bound interface for the applications, and user can also interact with the framework through the not-bound interface. And in the southbound interface, it will interact with the devices, sensor, and actuators. So I want to emphasize on the southbound interface because HX is mainly focused on the IoT devices. So it can only provide the southbound interface for the IoT, as you can see here. And inside the framework, SX framework include export services, supporting services, core services, and device services. The important thing is that HX is a project which does not consider OpenStack or Kubernetes Even the container is used in SX framework. So this slide is about the open edge. So for the architecture, open edge includes the master node and also include the worker node. In the master node, it provides uh, the programmable interface to interact with the agent and to interact with the IoT devices. So OpenEdge uh, is OpenEdge rely on the Kubernetes cloud platform, and it uses MQTT for the connection between the components. So OpenEdge shows the very simple design, and it's very well suited to the IoT use case. And also with OpenEdge, um, OpenStack is not considered because we know that OpenStack is very heavy. The next one is KubeEdge. So you can see in the name, the KubeEdge is mean that it is based on the Kubernetes. So you can see in the figure. So KubeEdge include the two layers. On top we can see the cloud side, and in the lower layer we can see the edge side. In the cloud side, you can see KubeEdge use the Kubernetes interface. And it can manage the container via the interface with the edge side. And for the communication between the edge side and devices, KubeEdge use the MQTT broker. MQTT is messaging services. And it's also same to OpenEdge. KubeEdge did not consider OpenStack. This is for the IO fork. So IO fork framework include only one component. This is about the edge cloud. So there, inside edge cloud, it can support the controller and the connector. So the controller will interact with the agent inside the devices to perform the life cycle. And the connector is responsible for the networking between the devices. So edge cloud is also based on the container platform. So I just present the overview of the real-world MEC frameworks. So this slide shows a summary. So you can see that we have a project like Aquino, Starling X, Airship, Cord, and Virtual Central Office, and they are different from each other due to the sponsors, the layer, and their cloud platform and networking platform. For example, you can see here Arc Rhino use the OpenStack and Kubernetes, but for Starling X, it's only considered the OpenStack. And for the SDN solution, Arc Rhino did not consider SDN yet, but in Starling X, it's used OpenDaylight. And for the airship, it's used Calico. And in Chord, it's used Onos. And for some projects such as HX, Battery, OpenEdge, and KuberEdge, they also have some slight difference. As you can see in this slide. For example, for this project, the same point is that they all focus on the IoT devices, and of course with different companies. However, they have different scope. With Edge X, the scope is about the common framework for edge solutions. For the framework like KuberEdge, the scope is about the attention of the containerized application orchestration. So I already present the management and orchestration framework. You, so so that you can get to know about the reference framework proposed by SC, and you can also have an overview of the real-world implementation of MECs. Thank you very much for the um, for the interest.